Okay, we're here. All right. I chose this problem because they ask this funny thing here. They want you to determine the ratio of the mass of Bonzo to the mass of Indar. All right, it's their little slick way of trying to be multicultural. They just use alien names. Let's just go to outer space because they've gotten in trouble before with being too cute with that sometimes. But anyway, Bonzo flies off with a velocity of 1.8 meters. So you got these two people, all right? You got these two aliens, and here's what they're doing. They all right. So you got the. I'll make this just a tad bigger. All right. So you got these two aliens, and they push off against each other. All right. Push off. Oh my! Wow, that was a gut, wasn't it? Anyway, so if I push off like this, right? Well, my desk stayed stationary because there's not a conservative. If we were frictionless, my desk would have gone that way, and I'd have gone this way. My desk might have gone, probably would have gone much slower because it's got much more mass, regardless of the gut shot you just saw. Has much more mass than I do, and so it would have taken off slower that way, and I'd have gone faster back this way. That's what we're doing here. That's all we're doing. But we got to look at But what we need to do is the conservation of momentum in the system. All right. So in this problem, here's what we've got. We've got Bonzo and Indar. Okay. I'm not stalling. There we go. So the initial velocity of both of them, initial velocity of Bonzo is equal to 0. The initial velocity of Indar is equal to 0. The final velocity of Bonzo is equal to 1.9 meters per second, or is it 1.8? I hate it when I do 1.8. Okay, and the final velocity of Indar is 4.9 meters per second. All right, here's the deal. You set up all these conservation momentum problems just like this. You go, all right, the momentum before of the whole system is equal to the momentum after of the entire system. Don't forget your negative sign on that 4.9 meters per second. Okay, so before I've got mass of Bonzo times 0 plus the mass of Indar times 0, because this is their initial velocities before, is equal to mass of Bonzo times positive 1.8 minus, I'm already factoring out this negative sign, the mass of Indar times 4.9. Okay? Well, this side is equal to 0. So the mass of Bonzo, and we're trying to find the mass of Bonzo to the mass of Indar. Okay? Mass of Bonzo times 1.8 minus mass of Indar times 4.9. So we've got this. We'll just say 4.9 times ME. While we're doing the algebra, we'll just bring this over here. Mass of Bonzo is 1.8. And then we flip-flop. We go 4.9 divided by 1.8 is equal to the mass of Bonzo divided by ME. Your numbers will differ, but what you can see is this is almost 5. This is a little less than 2. So Bonzo has about 2.5 times the mass of Indar. That's why Indar went backwards so fast. All right? Sorry I taught you how to suck eggs on that one and we did the entire thing, but it's okay. We'll do one more.